right, guys, so today we're going over the review sheet today. And we'll be finishing it up tomorrow, so we'll go through most all the problems. The only ones we won't go over are ones that are not going to show up on the test at all in that form, and it's just going to make it more confusing. Now, first ones we can look at is 1 through 6. Tell whether x and y show direct variation, inverse variation, or neither. Our direct variation comes in a few forms. Y is equal to a times x. Or we can say x is equal to a times y. And in both of these cases, both variables are in the top of the fraction. Or there's not one listed. Now the other way we could write this is that a is equal to pi over x, or a is equal to x over y.
I hope not. I mean, have you seen most of them grow over here?
I don't think that's it. I would laugh if that's it.
I think we'd all laugh.
Inverse. Y equals a over x, or x equals a over y. And the only other way that we have this is x times y is equal to a. So, these are our direct and inverse. And in the full video, I did this. I'm going to go the same way I'm going to do this here. Well, neither. What's the one big giveaway for neither? Addition or subtraction. So if we look at this here, number 3 is neither. Number 6 is also neither. So we have those there. I'm going to add one. X equals 7. Would this be direct, inverse, or neither? Because what do we always have to have? X and? We have to have 2 variables, yes? We have to have 2. We never really stated it specifically, but we really have to have 2 variables, yes? So that would be neither. If we only have one, it's neither. Because if it's just x equals or y equals, it's not direct or inverse variation. That's just a flat line or a line going straight up and down. We don't have any variation because we need 2 variables. All right, let's look at the rest of them.
Does your mom know what you're wearing?
Let's look at number 1. 8y equals x. Direct, inverse, or neither? Direct. Number 2, inverse. Number 6, or 4, not 6, inverse. And number 5, inverse. And with all these here, 1 through 6, we're just matching it up to one of the 2, or one of our sets of equations. Is it one of the ones that direct is modeled after, or inverse? One or the other. If we have addition, subtraction, or one variable, neither. We good with 1 through 6? Question on 7 through 8. No, we're not. They're not even showing up. So those 7 through, I did do one example of those in the full video, but really that's using the one where a is by itself. So for inverse, a is equal to x times y. If we multiply them together and get the same number all the way through, then it's inverse. If we divide them all the way through and get the same amount or same number for each, then it's direct. But we're not going to do those there. Now we can look at number 10 next. Now with number 10, these here simplify. Now in the instructions, I think on your paper it says list all restrictions. You don't have to do that. I'm not going to have you list the restrictions on the test because that just takes time and not a whole lot of time to do it, but it ends up not being anything. So we're not going to make you, well, I am not going to make you list the restrictions on this here. The only time it would be necessary to list the restrictions is if, when we're solving, the restrictions come back into play. And in the instructions on the test, I did look back at it. It doesn't say check your solutions. It said restrictions may come into play, or there might be restrictions. And there's only two problems on the test where you need to really be careful of the restrictions. Number 10, 2x squared over 3x squared minus 4x. Does the numerator factor? So our 2x squared. How many terms do we have? One. If we have a single term, 2x squared is not going to factor because there's only one thing there. We can't factor something out because it's just the one spot. A denominator, 3x squared minus 4x. Greatest common factor of x. 3x minus 4. And even though I sometimes skip over it because I do have a bad habit of doing that with greatest common factor, but if there, always be paying attention for greatest common factor. For rational expressions, if we do not have an equal sign with our numbers, we can't just divide it out. We have to actually factor it out. Questions on how we got to this here? Now we do have the multiplication on bottom, yes? Our x and x are in common, yes? So the 2x squared is going to simplify to what? 2x. So the denominator would be, and that's it. We can't simplify our 2x and 3x, or the 2x and 4, because the 3x minus 4 is a one term. It's stuck together. It's stuck together. And that's it. If anything on the test, especially with simplifying, multiplication, division, adding, subtracting is already factored, we have multiple sets of parentheses set up, don't distribute back through. Leave it as is. Because it's already simplified for us. We don't have to do anything with it. I did put a few of them where I already factored it down for you to save you guys time so you can work through them a little bit quicker. So if it's already set up instead of this here, it has two sets of parentheses, leave it. It's already factored. So, does that make sense? Because if we got 4x over as the starting point, go and simplify. You don't have to distribute. We don't have to do anything. It's already set up there. Let's look at 11. The denominator, 4x squared minus 17x plus 15, is their greatest common factor? No, but there is one somewhere else. There's a greatest common factor too, which would be 16x squared minus 25. Which is a difference of perfect squares, which we can go on and factor that. 4x minus 5 and 4x plus 5, yes? Now, seeing that is helpful because if something's going to reduce, one of the two denominators factors needs to be either 4x minus 5 or 4x plus 5. We need one or the other for it to simplify. So if we're factoring 4x squared minus 17x plus 15, since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. So most likely, yes, because our 4x squared, x and x. And if we're wanting something to match, we're going to go with 4 and 1 over 2 and 2. 15, 1 and 15, or 3 and 5, yes? So we would want 4x minus 5. And if we check this just to make sure, 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, giving us negative 17x like we wanted, yes? Now we can come in and fill this in down here. These will cancel, and the reason they'll cancel is because our 4x minus 5 and x minus 3 are being multiplied. Our terms are being multiplied in the numerator, leaving us with 2 times 4x plus 5 over x minus 3. And that's it. We don't have to do any distributing at this point. We don't have to multiply the 2 back through. Don't multiply the 2 back through. That's just a waste of time. Because that's it. This is our final answer. Questions on this here? We good with this here? I'm going to skip number 12. 12 is on the full video, and you're not going to have a difference of 2 cubes show up. I mean, no. I mean, it's still the properties of simplifying and solving. And even in the video, I just went on and straight out gave you what x cubed minus 27 is, which is x minus 3 times x squared plus 3x plus 9. And then we simplified. And in most of all this here, especially addition, subtraction, multiplication, division, it all hinges on factoring. We get it factored and go from there. 13, x squared minus 4x minus 12 over x squared minus 4. X squared minus 4, yep, x minus 2, x plus 2. And part of the reason we can just jump straight there as well, we can see from the outset x squared minus 4, there is no greatest common factor. So we can just go to factoring the difference of perfect squares. Numerator, x squared minus 4x minus 12. Again, no greatest common factor. Yes, since 12 is third term's negative, opposite signs, x and x. 12, we're going to want 2 and 6, plus and minus. We get this here. Then we can simplify our like terms. X plus 2 over x plus 2 will cancel. X minus 6 over x minus 2. And again, with these simplifying problems, all it is factoring. Once we factor it down, simplify what's in common on top and bottom, and that's it. Questions on any of this so far? We feel good with this so far. 14 is not going to show up on the test. We're not going to do monomial multiplications where we have individual terms, like this here. Not going to show up. All the ones that we'll have with multiplication and division are going to be like 15, where we have these polynomial expressions. And before we can multiply anything together, we need to factor it. What does not factor or is not factorable in 15? X minus 1 and 2x. Because if x minus 1 were to be factorable, it'd have to have a greatest common factor. Or the x would have to be squared. Because then it'd be x squared minus 1, difference of perfect squares. X squared minus 4x has a greatest common factor of x, yes. So when we factor that out, we have x minus 4 times our x. We have that there. And the only thing left to factor is x squared plus 3x minus 4. No greatest common factor. But because we have an x squared in a constant term, we're doing our 2 sets of parentheses. 4 is negative, so our signs are opposite. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. We want 1 and 4. And it'd be nice if the 1 was with the minus, because then we would have an x minus 1 on top and bottom. Now we can check to make sure. X times negative 1 would be negative x. 4 times x would be plus 4x. Giving us a positive 3x, so those are indeed the factors. Now at this point we can multiply everything together. Now again, with this multiplication, we do not need to distribute through. The numerator would be a bit much to try to multiply all that through, but our denominator, it might be tempting to do 2x times x, 2x times negative 1. But if we do that, we don't have two or more things multiplied together to be able to simplify. Because here, we do have the x minus 1 in common on top and bottom. Yes, because our x on top and bottom, since they're both to the same power, they cancel out completely, leaving us with x minus 4 times x plus 4 over 2. And again, there's no reason to multiply the x minus 4 and x plus 4 together at this point. It would give us x squared minus 16 all over 2, but it's the same answer. Questions on 15? Questions on this multiplication? Let's look at 16. They all factor, and there's one of them that factors easier than the other three. 2x squared plus 4x, because it has greatest common factor of 2x. We can factor it out, leaving us with x plus 2. Well, now we're hoping one of the denominators has a factor of x plus 2, yes? Which one do we want to look at next? X squared plus 4x plus 4. Third term's positive, so the signs are the same. Match the sign of the middle term, plus and plus. Only factors of x squared are x and x, and 4 has 1 and 4, 2 and 2. But to get something to cancel, we want it to be 2 and 2, and luckily for us, those are indeed the factors. Where do we want to move from here? Doesn't matter. Let's go with the other denominator to round it out. X squared minus 4x plus 3. Third term's positive, so the signs are the same, and match the sign of the middle term. Negative and negative. Only factors of x squared are x and x. And well, the only factors of 3 are 1 and 3. And that is indeed the correct setup. And that leaves us with our last set of factors. X squared plus 3x minus 4. Since the third term is negative, our signs are opposite. Only factors of x squared are x and x. X plus 4 and x minus 1. And that would be the correct setup. Because it'd be tempting to say 2 and 2, but if it was 2 and 2, that's the setup for a difference of perfect squares. Well, we can multiply this all together. 2x times x plus 4, x minus 1, x plus 2 is on top, over x plus 2, x plus 2, x minus 1, and x minus 3. A few things simplify. X minus 1 and x minus 1. X plus 2 and x plus 2. And that is it. Questions on this here? The denominator would be 1 for one of them. Because our x squared plus 2x minus 8. Since we weren't given a denominator, it's understood to be 1. Now we just need to factor the other 3. Where do we want to start? X squared minus 16. It is a difference of perfect squares. X plus 4 and X minus 4. It's a good place to start. Now it doesn't matter where we go. We just need to pick one. Let me start off with X squared minus X minus 12. Now, I will point out, and I think we already kind of noticed this, none of these expressions have a greatest common factor in any of them. So we're kind of just skimming past that. X squared minus X minus 12. Third term's negative, so our signs are opposite. And it would indeed be X plus 3 and X minus 4. Now we do have something already in common on top and bottom, yes? Nothing says that we can't just go on and get rid of it. Now our last expression, opposite signs, factors of X squared are X and X. Factors of 8 are 1 and 8, 2 and 4. Well, the only other thing we have left on bottom that could cancel is X plus 4, and then we'd have X minus 2, yes? And that does give us our middle term. Questions on this here? Well, we could have done this all along, but really, when we multiply, we're just sticking the numerators together, yes? So I could connect them and do what? Simplify the X plus 4s, leaving us with X plus 3 times X minus. Yes. If the numerator does simplify out completely, we need to leave it as 1. And the big reason is because if we had, say, 1 over 2 or just 2, these are not the same. Or 1 over 2 and 2 over 1 are not equivalent. We're not going to look at 18. The full video does have 18. Division, yes. One like this here, no. Because again, all the problems with multiplication or division are going to have these polynomials like 19, where we have to factor or do something to it. Now, if we do have a division like 19 and it's already factored, sets of parentheses, leave it. Just do our first step, which is keep, change, flip. Because if it was already factored, we just flip it and start simplifying. And if everything were to simplify out, it would just reduce to 1. Now we just need to factor. Where do we want to start? Let's just start at the first numerator. Now, none of the 4 expressions, top and bottom, any of these here, have a greatest common factor. Since the third term is negative, our signs are opposite. Factors of X squared are X and X. Now our factors are 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. For time's sake, I'm just going to tell you it's 5 and 8. 5 is going to be positive, 8 is going to be negative. Well, we can drop straight down. X squared plus 8x minus 20. 20 is negative, so our signs are opposite. Only factors of X squared are X and X. 20, 1 and 20, 2 and 10, 4 and 5. Well, interestingly enough, it's going to be 10 and 2. It's very It'd be very tempting to say 4 and 5 to get something to simplify out. But with that being plus x plus 5, it would actually give us a middle term of positive 1x, not our positive 8x. So nothing simplifies in the first expression. Now when we look at the numerator of our second expression, third term's positive, so the signs are the same and match the sign of the middle term, plus and plus. Factors of our x squared are x and x. Well, factors of 20 that we want, nicely enough, are 2 and 10, because that would give us a middle term of 12. And the last one, third term's positive, so signs are the same and match the sign of the middle term, plus and plus. X squared would be x and x, and the last 5 and 8. Multiply them together, now let's cancel. We would have x plus 5, x plus 10, and x plus 10, leaving us with so, and that was kind of a side thought I was having to myself too, is we had some earlier where we were able to pull the negative out and cancel, yes? If I pull a negative, factor it out of x minus 8, the 8 would become positive, yes? But the x would become negative. So it is very tempting to do that, but both signs would flip. The 8 would match up and be positive now, but the x would now be negative. So the only way pulling the negative out works is if both signs are opposite. So where the 8 signs are opposite, the x's would also have to be. If both of them were opposite, then yes, it would simplify out. Does that make sense? Yep. Questions on this here? Addition, subtraction. If the denominators are the same, we can go on adding and subtracting. Doesn't matter what they are. If they're the same, we can add and subtract. We don't have to do anything to it. Doesn't matter if it's just 2x minus 1 or 3x plus 2 here. If we have the same two sets of parentheses, go on add or subtract. We don't have to do a thing to it. Because for 20, the denominators are already the same. So we can go on and subtract the numerators. We don't need parentheses around this, even though it is subtraction, because each of the numerator is a single term. Just saying minus 1, we applied that negative to every term in the second one. Well, then we need to make sure it's not factorable. The numerator is indeed factorable. 4x squared, is it a perfect square? 2x and 2x, yes. 1's a perfect square. So we get 2x plus 1 and 2x minus 1 over our 2x minus 1. If we have two terms being subtracted, do check for difference of perfect squares. (21). All three denominators are the same. So we can add the numerators. Now we don't need parentheses for this one here. We could put them. There's nothing wrong with that. But because we're adding, the signs don't change. So there's no influence that the signs will have on the signs of each numerator. Subtraction does. but addition does not. Combine like terms. 9x squared plus 12x plus 4. We can indeed factor. Now there is not a greatest common factor, because it'd be good to look for it first, but there's not one. Third term's positive, so the signs are the same and match the sign of the middle term. Factors of 9x squared, well, we would have x and x. And if something's going to factor, we're probably going to need it to be 3x. One of them, well, it works out both of them are. Factors of 4 are 1 and 4 or 2 and 2. Because if something's going to simplify, we need a 3x plus 2. And it does work out that is the correct set of factors, and cancel, leaving us with plus 2. If it, again, if the 3x plus 2 had been left in the bottom of the fraction, the numerator would be 1. Questions on this here? We're going to factor first. Now, x squared minus 5 does not factor. Even if it did, not going to factor. Because we're going to have to combine like terms. So if we did factor it, we'd have to unfactor it to be able to finish the problem. X plus 3, our other numerator. So when doing addition, subtraction, don't factor the numerators. When solving, don't factor the numerators. The only time we need to factor the tops of the fraction is with multiplication and division, but at that point it's turned back into multiplication. The denominator, x squared plus 5x minus 14. No greatest common factor. 14 is negative, so our signs are opposite. Factors of x squared are x and x. Factors of 14 are 1 and 14 or 2 and 7. So it'd be x plus 7 and x minus 2. Now we need these denominators to be the same. Now they both already have an x plus 7, yes? But the one on the right is missing and an x minus 2. So we have to multiply the one on the right by x minus 2 on top and bottom. Because when we multiply, we'll have to put the parentheses back in. Now the one on the left, do we have to do anything to it? Are the denominators already the same now? Yeah, we don't have to do a thing. Because once the denominators are the same, we're good. It already has the x plus 7. They now both have the x minus 2. We don't have to do anything to it. So the one on the left is still going to be x squared minus 5 over x plus 7 times x minus 2. Now before we start subtracting, I think it's easier to go on and simplify this second numerator before we actually start subtracting and doing all that, less to take care of it or work with at the same time. Distribute x squared minus 2x. Distribute our 3 plus 3x minus 6. And then combine like terms. The question is how we got to this point here. We feel good getting to this point. Yes? It'd be nice if one problem started out here, yes? Because if it started here, do we have to do anything? No, the denominators are already the same. Even though they're factored, they're still the same. And that's the key when adding and subtracting, is making sure the denominators are the same. No matter how they look, if they're the same, then we can add or subtract. So it'd be kind of nice if there was one that started out here on the test, yes? Okay, I think I laid enough emphasis on that. Because if it started here, or we got to this here, at this point we would subtract. Now, again, if it's on the test set up like this here, and it was adding the two, we would add them. If it's subtracting, we would subtract them. Now, the reason I put parentheses around this one here is because the numerator that's being subtracted has 3 terms, and that's not our bell, because it's only 44, not 49. Because here we have to apply that to all 3. The first one stays x squared minus 5. Now we have negative x squared minus x plus 6. So with this one here, we had more than one term being affected by it, so had to make sure we distributed through. If you feel comfortable distributing that negative, instead of putting the parentheses, do that. But if you feel more comfortable with putting the parentheses and then distributing, do that. X squared minus x squared is 0. They're gone. Well, now we just have negative x. Negative 5 plus 6 is plus 1. Now, for the most part, we would factor at this point, because we could factor that negative out. We could leave it there. Here, neither here nor there. The main reason we would need to factor it out is if there was a x minus 1 on bottom. Because the x minus 1, negative x plus 1, the signs are opposite on both, then it would simplify out. But that's your final answer. And especially with simplifying or factoring, the main place it will cost you points is if it does reduce. Pretty good with 22. 23, where we have 3 different things being added or subtracted, is not going to show up on the test. The most you'll see is 2. Like 22, where we have 2 expressions being added or subtracted. There's going to be one with like bases already. There's going to be one where we have to do something to get them to be the same. There's not going to be one like 23. On the full video, I start going through that and then decide that it's more confusing to try to go through that and show you that entire process. And there is a little bit of a pause in there because I'm looking at the answer, and the answer doesn't even factor. It's a cubic, so partway through starting that, I just threw it out. And it was also starting to get pretty late, and my wife was ready to go home at that point, so I was trying to speed it up as much as I could. But we do have time for one more, because these here are nice in that they're a little bit quicker. We can look at 26. With any of these here for least common multiple, factor them all the way down. Factor them all the way down. 2x squared, factored. 4x plus 12. We can take a 4 out, leaving us with least common multiple. I always look at our expressions, our terms in the parentheses, those factors first. The one on the right has an x plus 3. So we need it at least once. The one on the left doesn't have it at all, so we have it only once. Now we need to make 4 and 2x squared be the same, yes? Well, we'll need n. What's the first number we can turn both 4 and 2 into? 4, because least common multiple, we're going up. The greatest common factor between 2 and 4 is indeed 2. So it is 4. Least common multiple, we're trying to make them be the same. Like our addition, subtraction, we're trying to get them to be the same, so we're always going up. So it can be equal to it, it just cannot be less than 4 in this case. Because we don't want to have to divide, we're always looking at multiplying to get them to be the same. So to get 2x squared to become Our 4, we multiply it by 2. To get the 4 to get there, we multiply it by x squared. Does that make sense?
Yep.
And that's all the time we have.